we have. Yeah, I understand when people get here a bit late. My own, I actually, for me, it takes me like 5 minutes to log in to Zoom. I don't know why. It's very weird, but every time that I just open a new the Zoom client, it just takes forever, and sometimes it just crashes. So.
Oh, that's weird.
Yeah. That's why I added a lot of co-hosts, you know, just in case.
Just in case something goes wrong. Yeah, that makes sense.
Yeah. Hey, so what did you end up doing with your website? Because last time we spoke, you were trying to use Blockdown.
Yeah. So I was able to use Netlify, or able to connect it with Netlify to actually host it on the web. So it works now. I remember before I was having issues with like the Hugo version, and it wasn't like updated or whatever with what Netlify wanted to do. So now it works. But thanks for all that help. It was just frustrating to put in all that work to like make it, and then not even being able to like.
Yeah. No, I haven't
updated in a while though.
I kind of like switched gears, and I went fully rogue, and now I just have a single page website with a profile, not even a profile, just it just has links.
Okay.
So, and I have like a separate GitHub repository where I list all my presentations and papers. I just linked it to the Google Scholar profile, and what else? And I don't remember, but I have like I don't know, just a few loose GitHub repositories linked to my website.
Okay. Nice.
So give me 1 second. Just me and the last couple of people. Okay, so I think we are good to go now. So good morning, everyone. Welcome to the second day, the second presentation of this year's virtual R Bootcamp. Today we will have Eric, who is a postdoc here at Biostats. He's a PhD. He got his doctorate degree in biostatistics from UCLA, right? Right, Eric? Yeah, you got that right? Yeah, and so he will be talking today about data wrangling using dplyr. Again, as yesterday, so we have all the slides are available online. I'm going to just copy paste the link to it, so you can, if you go to that website that I just added to the chat, you can go there and download the entire presentation. It's an HTML file. The markdown, the source code used to build this presentation will be uploaded later today. And as you notice, we are recording this session. So Eric, it's all yours.
Thanks, George. Good morning, everybody. I'm really happy to be here. So today we'll be talking about dplyr, which is a package in the suite of packages known as tidyverse that allows for easy data wrangling and data cleaning and manipulation. So just to preface this talk, if you're going to be in the field of biostatistics or public health data science here at USC, you're going to be taking these statistics courses, and with these courses, you're going to like learn how to analyze data. Typically, for your homeworks or your labs, the data is already clean, so you just have to open the data and then run whatever method you want to run on, and everything's perfect. However, in a collaborative environments that I'm usually working in, the data that you get initially isn't clean at all. You're going to be you need to create variables, you need to subset the data so that you're only looking at a specific population. There are all these issues going on, and that's the data that you have. And so there's going to be a little bit of time or work that you need to transform the data that you have to the data that you need. And so that form is known as data wrangling. So what is data wrangling? The Wikipedia definition of this is the process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes, such as analytics. The layman version that I like saying is just it makes data easily accessible and readable. That's all you're trying to do. You're trying to get data that you have to become data that you need. And so to do this, we're going to first talk about data frames. You guys should be familiar with them. I believe Natalia talked about this a little bit in her talk. But a data frame is a special structure that you have in R. Essentially, it's like a matrix, except that the matrix, you have columns and you have rows. And so here, what you have is that you have columns that are variables. So these could be things like an outcome, gender, race, ethnicity. They could be like quantitative measurements, BMI, height, and weight. And each row will contain one set of values for each column. So data frames typically have the following. So the column names should be non-empty. Typically, if you don't assign a column name, it'll be something like V1, V2, V3. The row names should be unique. Again, you could think of these as like unique IDs. So every row is a subject, or if you're looking at longitudinal data or cluster data, which are data forms that are, primarily used in a lot of health research, then a set of rows, a collection of rows would denote one subject. So the data stored in a data frame can be several factors. It could be numeric, so numbers. They could be factors, so gender, male, female, race, ethnicity, or they could be a character type. And so this could be like blood type, A, B, O, O positive, A, B, O, and then if you want to include the positive, negative, you can as well. And so typically all numerical matrices, like just a matrix of numbers, can be converted into data frames, but not vice versa, just because you have these factors and these characters as well that can't be transformed into a numeric value yet. So that's just a little thing you should understand. The reference to this is given below. The only thing you need to know from this slide is that we're working with data frames. And those are typically what you're going to be getting or using in R. So an example would be the diamonds data. This is the one you saw from Natalia yesterday. So here we're just opening up ggplot2, just calling the diamonds function here. And then diamonds would, you just write diamonds and it'll output the actual data frame. If you see here, we're going to have around 54,000 rows and then 10 columns. So it's each column here will correspond to a unique variable. So you have carat, cut, color, clarity, depth, table, price, X, Y, and Z. These are all going to be your unique variables. If you want more information about this, you could open up the help file. So $diamonds, at least for this data, because it is already given to you in ggplot2, you'll be able to see what all of these mean. So when you first look at this, I think the first four are pretty obvious. When I went ring shopping for my wife, I had to understand what the 4 C's were. So this was something that I'm pretty well versed in, but the other things like depth, table, price are a bit more unique. Even X, Y, and Z, like I'm not sure what they are. So if you want to know what they are, at least for this data frame, you can just open the help file. But typically, if you have a data frame and you don't know what the variables are, you should talk to the PI or whoever is providing you the data. Usually there's some sort of data dictionary that'll be able to link the variables to a certain definition. So here we can see that every row is going to correspond to a specific diamond. So these are all unique diamonds. And so then each one is going to be provided, is going to be given a row. So here we have about 54,000 unique diamonds that we're looking at in this inventory. So typically, as I said before, the data that we read in can't be readily used. If you look at data analytics, sometimes you need to remove certain subjects that don't meet a certain criteria. Maybe you need to define new variables. Sometimes like you'll have height and weight, but you're interested in BMI. So you have to actually convert BMI using height and weight. Sometimes the height and weight aren't in metric units, and so you have to convert from say feet in pounds to kilograms and meters, and then from there be able to do BMI. So those things are all going to happen, which is very common in statistics, or very common in data cleaning. Another thing here would be to extract summary statistics. So if you're really interested in looking at, let's say, classrooms, and you want to find the mean per classroom, you're going to have to find a way to organize data such that, you get all the test scores for one classroom, and you take the mean of that, and then for the second classroom, take the mean of that, and so on and so forth. So a decent amount of time can be taken to ensure that you have the right structure before proceeding to perform statistical analyses. I say amount of time, but it's also lines of code. Sometimes our code could be super messy. It could be, I know people who clean data and it's like 50 to 100 lines of code just to get the data to be the format that they want. When you do multiple things like extracting data, creating new variables, subsetting subjects, it can start to get complicated. And then lastly, we have to worry about code readability. So what I mean by this is, typically when you're working in an internship or when you're working on a project, you might for some reason be pulled off that project. Maybe you're leaving that internship, maybe you're getting a new job, or you're being switched to a different project. In that case, someone else is most likely going to be taking over your job. And if they can't read your data, or they can't read what's going on or what you're doing to clean the data, then it's sort of double work for them, because the work that you did is kind of useless if they can't even use it. And then the second thing is they're going to have to redo everything you already did before they could do what they need to do to proceed. And this is really important, especially for like internships, where I worked 2 internships during my time at UCLA. Both of them required me to, read in data and clean data before analyzing. And the thing that they always wanted me to do was, after I was done with my internship, to give them my code. And so I had to make sure that I commented the code and made it as clean as possible, so that if someone else is taking over my project, they could just jump right in without having to read every code line by line and dissect everything that I'm doing. It should already be there for them. So the question that we want to ask is, well, can we clean and wrangle data using nicer syntax? Is there a way to make this easier than it currently is? And so that's where we talk about the dplyr package. So the dplyr package here, the reference is above. It provides a set of what I would call verbs, and this helps you solve most common data manipulation challenges. It's part of a larger suite of R packages known as the tidyverse, and this is by Hadley Wickham and his group. ggplot2 is another one that's in this suite of packages. And just a little side note, Hadley Wickham actually won the COPS award in 2019, last year, which is kind of the equivalent to like a Nobel Prize in statistics for his contributions to the tidyverse and everything he did to make our studio more accessible to just everybody in the world, not just purely for statisticians. There's also a cheat sheet here if you guys would like to click it. You probably have this. It's in the slides. But this cheat sheet kind of shows you all the major components of dplyr and how you can use that to manipulate the data the way you want it to. Today I'm only going to show you just a few of the commonly used dplyr functions. So this is going to be select, filter, mutate, summarize, and group by. There are plenty more, but these are the ones that, at least for myself, when I do my own research, these are the ones that are the most commonly used. And I think looking at a few other dplyr intro slides that people have written, it's around the same amount. The intersection is around these 5 functions. So before we get started, we're going to install the package first. If you want to open up R right now, this would be a great time to open up R or RStudio, and we're going to install the package. If you already installed tidyverse, this should already be in there. As I said, tidyverse sort of loads all these packages, but if not, you can install this package directly using these 2 functions. So just install .packages, dplyr in quotation marks. It might take a few seconds to load, and then from there you can just hit library dplyr. And then from there, you'll be able to access the dplyr library. So first, we're going to talk about select, which is a function to subset data column-wise. So the select function allows you to select columns or variables, in this case, in a data frame. The syntax is as follows. So if you see select XY, this is equivalent to saying or doing select the variable Y from data frame X. So note that Y here can be a vector of column names, or it could just be just the numerical positions in the data frame. So if you remember, caret was the first variable in the data frame. So you can select from diamonds caret in quotations, or you could just input the number 1 since it's the first column. So I'll show you a quick example here of what we're doing or how to use the function. So here, select diamonds caret price. You're just retrieving those two variables, caret and price, from diamonds, and you're making that its own separate data frame. So you can store this as, say, diamonds sub, diamonds caret and price, or however you want to name it, and it'll be a data frame that just contains these two variables. So we're gonna I'm gonna give you guys a little bit of time to do an exercise. You could do this in R, or you could just do this in your head if you wanted to. But the exercise here is to create a data frame, diamonds underscore 4C, that contains the 4 C's. So the 4 C's here, in terms of a diamond, are the cut, clarity, color, and caret of a diamond. So what I want you to do is, name it diamonds 4C. We're going to assign this. And then what these 3 ellipses are, this is where you're going to fill in the necessary inputs to be able to extract the data frame that has the 4 C's. And if you need to remember how the the format looks, it's going to be something like this. So I'll just keep it on this. I'll just keep it on here for a few seconds to get you guys familiar with the syntax, and then I'll move it back to the original slide for the exercise. And I'll show you the answer in a minute.
I actually never heard about any of those things. Caret, color, clarity, caret.
Yeah,
so
it's yeah, I went to the jewelry district in downtown LA when I was looking for rings, and they were telling me all these things. It was pretty overwhelming at first.
I can bet. Yeah.
Yeah. I feel like caret is like the one most people know about. It's just like it's the size of the ring. The other ones are a bit more like, there are slight differences. Like the color is like, I think it goes from like a yellow, like the grading scale is like a yellow to a pure like clear diamond. Right. And so it's like the higher the color, the more expensive it's going to be.
Right. No, and I guess that if they were telling you about those things, you actually needed to learn about it, otherwise you will be scammed, right? You will be tricked.
Yeah. It'd be so easy to be tricked or fooled. And I mean, even some of these things, like they could write it like, oh, this is like a color of something, but I'm not an expert, right? So like I wouldn't be able to tell. Right. Like, oh, this is actually not priced the way it should be priced.
Right. Yeah. The problem is that because of that, they will like just tell you that and raise the price because I don't know, it's clear. So
yeah, definitely. So I think we gave people a little bit of time. So I'll show you the answer. So here, it's very simple. So it's select diamonds, since that's the data frame that we want to work with. We're going to just extract cut, color, clarity, and caret. And if you do so, diamonds underscore 4, when you type in diamonds underscore 4C, you should get a data frame that still has around 54,000 rows, but only 4 columns. And the 4 columns are going to be cut, color, clarity, and caret. One thing you'll see here when you look at this data frame is there is this extra column here that's not part of the actual data frame, it's just part of the presentation, but it shows you the structure of those specific variables. So here, DBL stands for double, which means like caret is just going to take a double value, which just means that it's going to take some sort of continuous measurement, decimal, integer, whatever. So 0.23, 0.21, so forth. ORD stands for ordinal. So it's a character, right? Like these aren't numbers, these are just, you know, strings, but they have a certain intrinsic order to them. So I forgot a lot of these, but you know, in this case, you can see that I think SI1 is going to be less than SI2. SI2 is going to be less than VS1, and then VS2, and then VVS2, VVS1. There's like a naturally order to like better or worse. And same thing for cut, same thing for color. So those are ordinal factors instead of just regular factors. So that's how you. So, go ahead, Emma.
Yeah, so you can look at the ordering. Like the ordering is coded into the variable. So if you look at it individually, it will show up in the print method.
Yeah, so if you were to type in a thing like diamonds_4C $ color, you'll get the vector 54,000 ordinal values, and on the bottom it'll say what the ordering should be. It's like something greater than something greater than something greater. So you can see the actual order of that. So that's how you subset data column-wise, which is pretty important if you want to shrink your data set. Sometimes you'll have hundreds of variables, but you only need like 4 of them. The second thing is subsetting the data row-wise. This is done using the filter function. So the filter function allows you to extract rows that meet some logical criteria. And so here, filter XY, the syntax here is, you know, retrieving a data frame that extract the rows of X where Y is true. For those of you who aren't really familiar with like the logical, with like how to do logicals in R, there's a section in the back in the appendix to show you how to do that. And I'll give you a quick example of how that'll look. So here, I'm filtering from diamonds prices that are less than or equal to 2,000. So all this is going to do is it's going to look at the diamonds data frame. It's going to look at price, and any price that's going to be less than or equal to 2,000, it's going to output. And anything that's greater than that, it's going to remove it from the data frame. Well, not remove it, but the new data frame won't have it in there. So this, again, is a new data frame that just has all the prices that are less than or equal to 2,000. And you can see here that that's about 24,300, I think. Or sorry, 24,207 entries. And so we shrunk the data set dramatically using this. And so this is kind of important or relevant if you want to do, say, you know, inclusion, exclusion criteria when you want to look at subjects. So maybe you want to include subjects that are, you know, of a certain, you know, that they came into the study at a certain day, but not past a certain day. So you kind of have a time interval of like the entry of study. And that's usually what would be used for an exclusion an inclusion criteria. For exclusion criteria, it could be, you know, maybe subjects who have some sort of erroneous value for their weight. Maybe it was miscalculated, or maybe there was a data entry error. So you want to like remove those subjects. You could do that as well. So here's going to be an example. And so the example here is that, so let's say that the diamonds data set is your data set, right? That's the one that you have. That's like your inventory of diamonds. Someone and a customer arrives at your store and they only want to look at your quote unquote finest diamonds. So when talking more to the customer, you realize that their criteria for diamonds that they're looking for includes diamonds that are both ideal in cut and internally flawless in clarity. So what you want to do here is create a data frame, diamonds_fine, that contains all diamonds that meet these criteria. So what we're going to do here is I'll show you how this will look. And the way it'll look is that I'm defining diamonds_fine as my new data frame. I'm going to filter from diamonds these two. So here we have, I want to filter where clarity is equal to IF. This is internally flawless clarity. And then where the cut is equal to ideal. So the logical in R here is equals stand for, you want to show if the value of that vector is equal to the specific string. So you need 2 equal signs for that, because generally the 1 equal sign is just assigning a new variable. And then since you want to look at 2 separate arguments at the same time, you want to use the AND operator. This kind of just shows that both of these have to be true in order to be, in order for the logical to be true. So, you know, you want both clarity being internally flawless and you want the cut to be ideal. And when you do so, this is how the data set's going to look. Diamonds underscore fine. If you were to type this into R, you're going to be given a data frame that has about 1,200 diamonds. And you can see here that the clarity is going to be IF, and then the cut's going to be ideal. And those are the only two things that have to be the same across all the rows. And you know, as you can see here, we didn't select any columns, so we're going to be given all 10 variables as well. So that's filter. Hope it's easy to understand. So select is what you would use to extract the data column-wise. Filter is what you would do to subset the data row-wise. The next thing that we would do typically will be change or create variables. And this is using the mutate command. Seems kind of intuitive, right? Like you're mutating a variable. And this could be either by creating a new variable or by changing an existing variable. So that's done using the mutate function. Again, the syntax is as follows: mutate x and then y equals some argument. And what this specifies is you add column y to data frame x, where y equals some sort of argument, which I'll go over later. If y already exists in the data frame, then all you're doing is replacing y with this new argument. You can change or create multiple variables using one passive mutate. So just like how in filter and in select, you could select multiple columns, you can also mutate multiple variables in R as well using dplyr. So here's an example of how mutate looks. So I am looking at diamonds underscore 4C. This is the data frame we created that had just the 4 C's, cut, color, clarity, and caret that we did in the first exercise. And all I'm doing here is I'm creating 2 new variables. So I'm defining this variable caret squared as just equaling the value caret squared, right? This is just mathematically how you would calculate the caret. And then caret underscore cubed is doing the same thing, except we're just cubing that value. And as you can see, if you look at the data frame, we changed nothing, right? We still have 54,000 rows and the 4 columns we had from diamonds 4C, but we created 2 new variables, caret squared and caret cubed, which is just going to take this value, squaring it, this value, cubing it. And so that's all it's doing. And it's pretty straightforward, I hope. If you have any questions, feel free to write it in the chat. I think a lot of people are active in the chat, so I'm really happy to see that people are asking questions. And thanks, George and Emil, for answering them. Again, what I'm doing here is I'm doing another thing. I'm actually just redefining a variable. So before, as I said, you can create new variables, and that's what we did here. We created caret squared, we created caret cubed. The second thing we can do is change a variable. And so all I'm doing here is the same thing. I'm looking at diamonds 4C, but now I'm changing clarity to be a numeric value. So remember how I told you that clarity itself was a ordinal variable? The ordinal variable is just a variable where the string has an intrinsic order, and all I'm doing is now I'm converting that to be a numeric value. So, those are going to be like a VS2 less than VS1 is the same thing as saying like 1 less than 2. And so all I'm doing here is I'm just transforming clarity into a numeric, and you can see that all this did was it just swapped clarity from being that ordinal factor to just a numeric value. It's read the same exact way, but in this case, you're changing it to a number than having it remain as a string. So in this case, I'm just mutating or changing an existing value, an existing variable in the data frame. So with that, I'm gonna give you guys a little bit of time to do this exercise. So it's lost in data translation. So suppose you have a buyer in Japan who's interested in purchasing diamonds from your inventory. Again, the diamonds is your diamonds data frame, that's your inventory. An employee sends them over the data frame, and the buyer enthusiastically requests to purchase your entire inventory. It sounds great, right? But while initially ecstatic, you soon realize that the employee forgot to convert these prices from dollars to yen. Which, if you would understand, this is a huge bargain if you're buying it in yen. So yikes, this is not a good thing. So instead, you want to send them the new revised data frame that actually has the correct value and prices for yen. So what you want to do here is create a new data frame, diamonds_yen, that replaces the variable price with the price in Japanese yen. And so you can disregard this part, just look at this hint. So this hint is telling you that $1 is equal to, I think from yesterday's exchange rate, it was 106.6 yen. So with that in mind, I want you to try to, look at the diamonds data frame that you had, and then using the mutate command, try to change the price variable into one that is representative in yen instead of dollars. So I'll give you guys, again, a few minutes to, maybe a minute to do this.
There must be another package to do the conversion like live, right? I'm just guessing. Someone should have written another package that allows you to do like a monetary conversions with the price of the day at the moment.
Yeah, I think there is. I think there are some packages in like there are some like packages that look at stock markets. They look at like stock prices. You could do one, I think, for currency prices too, and you could just say like from USD to, yeah. So I think there are actual ones that can do that.
Right. When I discovered that you can do that conversion using Google, I don't know. I loved it. So now I constantly use it because I usually like send money back to Chile because I'm from Chile, and I always like keep track. I don't know. It's great. Great. I don't know if you have used that.
Yeah, I used it a lot. I mean, I used it to get this conversion rate.
Right.
Yeah. All right. So I think that's a bit of time. So I'll show you guys how it should look. So here, diamonds yen is what I'm calling it. You're mutating diamonds data frame, and price is just going to be 106.60 times the price that we have, right? The price we have is in US dollars, and so we want to multiply that by 106.60. So that's what we have here. That's the conversion. And so this is the new price that we would get in Japanese yen, which is far different than if you were to show this price in US dollars. So that's like, in this case, I'm just replacing this price variable. The next function we're gonna look at, so we looked at select, which is for column wise, filter, which is row wise, mutate, which is to create or change variables, and then summarize is going to be used to summarize the data. So what this is doing is that it creates a new table, a new data table, a data frame of summary statistics. And this pretty much maps a vector to a scalar. What that means in layman language is essentially when you type in summarize x, y equals f of z, z is another variable in the data frame. You're applying f to the variable z in data frame x, and you're calling it y. So some examples of this would be sum z, which is going to give you the sum of the vector. So if you had price, it'd be the sum of the prices. Mean z would just be the average. So it's the average of the prices. Median would be the median of the prices, and then min and max as well. You can also create user-defined functions as long as it takes a vector and returns a scalar. And then you can use that in your summarize function as well, as long as it's predefined in your environment. Summarize works with the Z at the end, and so with an S at the end. I think it's like British spelling versus English or American spelling. Both work as well. So if you want to use summarize with an S, that works just as well as summarize with the Z. So here's an example. What I'm doing here, like I said, the syntax is X, Y equals F of Z. So here, summarize, from the data frame diamonds, we want to create a new variable, average price. And this average price variable is just going to be the mean of the price vector that we have. And when you do so, since I'm not stratifying this at all, I'm just looking at the mean of the prices, you're just going to get a data frame that has one entry, and that one entry is going to be the average price. You can also use user-defined functions. So here, this is a little bit useless, at least in terms of price, but I'm just looking at the sum of the squares. So I'm taking the price variable or value, I'm squaring it for each of the variables in the vector, and I'm summing it together. So it's a sum of squares. So here I'm summarizing diamonds, SSQ underscore price is what I'm calling this, sum of squares price. And that's going to be equal to the sum of square of the price as defined by this function. Again, you get a data frame that has one entry, which is going to be the sum of square of the price, and it's going to be this abnormally large value, which is what you'd expect, because when you square a value and you sum it, it's going to be very large when they're all greater than 1. So again, this is like a useless metric, but this is just showing you just an example of how you can use a user-defined function in the summarize package, or in the summarize function. You can also output multiple summaries, so not just one, but diamonds. But here I'm looking at mean price and median price to see if there's a difference between the mean and the median. And so what I'm doing here is I'm defining mean underscore price as the mean of the price, and then I'm defining median underscore price as the median of the price. And so if you go look at here, as I said, you have a data frame, but instead of having one value, you have two values, right? You're gonna have one for the mean price and then one for the median price. And so that's all you're getting from this. So summarize, just in conclusion, you're taking a vector and you're going to be returning a scalar value. So you're taking the vector price and then you're going to summarize that into one number. Notice that this disregards the other variables in the data, right? Like I'm not looking at carat, I'm not looking at color, I'm not looking at clarity or X or Y or any of the other variables. I'm just solely looking at price and applying some function to it. Sometimes we're not interested in this. Remember, as I said before earlier, where we might be interested in test scores grouped by different classrooms, right? In this case, we don't want to look at the one value. Could be looking at the average test score over all classrooms, but we might also want to look at like the average price within classrooms. And so you might want to look at group specific means or group specific summaries. So in the example for the diamonds data set, maybe we're interested in looking at the price, the average price, but instead of the entire average, we're going to look at the average price based on cut. So how do we do this? We can what you can do is you can filter the data and make a bunch of mini data sets, each with a specific cut, and then summarizing this. But that'll take a lot of code to do, and that won't be as efficient. The next thing you can do is use this group by function. So the group by function will just group the data. And with group by, what we do is we specify a variable that we want to, as we would expect, just to group by. So now any functions we apply via summary will be based on the grouping. So here's an example of that. So here what I'm doing is I'm calling diamonds cut as the function group by, where I am grouping diamonds by cut. And all this is doing is it's kind of giving a memory to this data frame, telling them that, okay, whatever summary function I'm going to be doing is going to be done based on the group. So it's like a group specific function. So here, diamond underscore cut, I'm grouping diamonds by cut, and then I'm summarizing diamonds cut by the mean and median price again. But we can see here, instead of just having two values that we had in the previous data frame, right? The previous data frame only had mean and median for the entire data frame for all prices, regardless of cut, regardless of clarity. What I'm doing here is I'm looking at the mean and median specific for a certain cut, right? So here we have for diamonds that are of a fair cut, here's the mean, here's the median. For diamonds of a good cut, here's the mean, here's the median, and so on and so forth. So in this case, this is a bit more descriptive, right? We're more interested in looking at this. And so this is what the group by function does. Sometimes, we want to apply more than one transformation. So just just sort of as another checkpoint, we looked at those 5 functions that we're interested in looking at. We looked at select, filter, mutate, we looked at summarize, and we looked at group by. And those are the 5 more of the common ones to look at for dplyr. Typically, when we look at data frames, we don't just do one transformation, we do multiple, right? Like we want to filter and then summarize, or like in a mutated variable and then summarize based on some grouping. And so when this happens, it gets a bit more complicated. So suppose you want to create a data frame that only has cut, color, clarity, and caret, but also filters based on cut, so ideal, and clarity. How do we do that? We're just combining the first 2 examples into one, into one example. So the first naive solution is many data frames, right? We can first, do select, and then from here we can filter, and then this diamonds underscore solution sol1 will give us what we want, right? It only gives us cut, color, clarity, and caret, only for those that have an ideal cut and internally flawless clarity. This is, just 2 separate functions, 2 different data frames. The second one would be nested data frames, right? We can sort of nest them how you would nest functions, right? So we're going to first do what's inside the parentheses. So we're going to select these columns, and then we're going to filter the rows. So this is diamond underscore sol2, and you get cut, color, clarity, caret, with all ideal cut, all internally flawless caret. Same thing. We get the same exact answer, but 2 different ways of doing it. One is doing multiple data frames, one is doing nested data frames. Both solutions are correct. And you may be able to get away with this when you only do 2 transformations. It doesn't seem too bad. But what if you had to do like 4 or 5 or 6 transformations? Then you're going to be having a whole bunch of data frames, or you're going to be having a whole bunch of nested arguments. And it can be very confusing and hard to read. Again, if you're giving this code to somebody and they're just like, I have no idea what's going on. But fortunately, there is an easier way of doing this. And that's using the pipe function. And so the pipe function is essentially a transformation of a data frame to another data frame. You could think of it as more of like a mathematical function. So when you do z, x, pipe f, it's the same thing as saying apply f to the data frame x and call it z. So sort of like, z equals f of x. And we could even pipe consecutively. So just like how you can do it in mathematical functions, you can pipe, x to f, f to g. So the question here is that, but what about the data input for dplyr for the functions we learned? The pipe function is specifically built to use the data frame from the left-hand side. So when you say x, you want to pipe select y, what this is going to be doing is this is equivalent to saying select x, y. So this is the data frame, and this is the function you're using. These are the columns in data frame x that you're trying to extract out. So as an example, how this would look for our previous example that we did, when we wanted to both select the 4 C's and then filter based on clarity and cut. And that's diamonds underscore solution 3. We're using the diamonds data frame. We're going to be piping, and we're going to be selecting from the diamonds data frame these 4 variables. And then we're going to pipe, and then we're going to filter based off of clarity. And so this is going to give you, again, the same exact solution as diamonds underscore sol1 and diamonds underscore sol2. So this is another one. I'll give you guys a few minutes, just maybe a minute because we're running out of time. I'll give you a minute of just thinking about what this is doing. So I'm diamonds, and I'm piping this function, and I'm piping this function. Disregard this one. I forgot to talk about this. This is in the appendix. So just look at these 2. What is this doing? Just kind of think about it for a minute, and I'll tell you guys what it's doing. All right, so hopefully that was a little bit of time to just think about this. Remember, we went through all these functions individually before. So what we're doing here is from diamonds, I am grouping the diamonds by cut. And then from there, I am creating a new variable, summary variable average price, which takes the mean of the price. So again, this is taking the average price by cut. And that's going to give you the data frame that we have here. So with that being said, let's see. So with that being said, I'll just leave a final exercise for you. I'll give you this, maybe like 3 minutes to work on this, at least thinking about it. But suppose we're interested in plotting the average price of diamonds by clarity in terms of their price in Canadian dollars. Again, 1 United States dollar is equal to 1.33 Canadian dollars. So the first thing I want you to do is create a data frame that contains the mean price of diamonds in Canadian dollars based on their clarity for diamonds that meet the criteria below. So you want carat to be greater than 1, you want clarity to be greater than or equal to VS1, and you want cut to be greater than good. And then you want to use this data frame to produce a plot that plots the mean price by clarity. So this is sort of doing what you learned in Natalia's presentation yesterday, but just applying it to a data frame that you create today. So you're kind of mixing both what you did yesterday with what you're doing today. So I'll give you a little bit of a hint. So this is how the layout's going to look. So you want to have diamond underscore final. This is going to be the diamonds data frame. You're going to mutate because we have to change the price. You're going to filter because you only want to look at specific diamonds. You want to also group by because you're interested in looking at mean price based on their clarity. So you want to group by clarity, and then you want to summarize because you're looking at the mean price. So I'll give you guys about 5 minutes to work on this. And then again, after you create this data frame, you're going to then plot the data frame. And so how would you plot it? You want to look at diamonds underscore final, and you want to look at clarity versus average price, Canadian dollars. And so with that being said, what would your X and your Y variable be in this case? And so I'll give you a few minutes. At this time, I could take maybe a few questions while we look at this, because this might take a little bit of time.
Yeah, sounds good. Let me see. You can throw in your questions into the chat, or I think you guys can. Yeah, you can unmute yourself. So if you want to make a question, you can do it right now. I think. Oh, actually, yeah. Now you can unmute yourself. So if anyone wants to say something, ask a question, go ahead. Yeah, so one clarification though. So yesterday we were looking at the AES function there for plotting ggplot. You can do the mapping. Also, we did it in geom point actually in the geom instead of putting in the ggplot function. But that's okay. So you can do either way will work. So you can specify your X and Y variables in the ggplot function, and you can do the same using specifying it in the geom that you're applying. So both are okay.
Seems like most of the questions that were in the chat were, well, I think all of them have been answered.
Yeah, so somebody asked if it's a good idea to keep multiple copies of your data. Yeah, in your presentation in particular, you were doing that because you were like reusing the diamonds data over and over to show what you can do. But usually you will just keep a single copy, or unless you are, I don't know, it depends on the task. So Amy made a very good point there. The fact that in the most recent versions of R, I think is starting the fourth R. Like R 4.0, Emil, maybe I'm not sure. But
no, it started a while back, but it got even smarter in 4.0.
Okay. So the thing is that R is smart enough to keep track of what things are different or not. So if you make a copy of a data frame and you don't modify it, it will actually, both will be pointing to the same space in memory, which means that, for example, if you have a data set that weighs 1 gigabyte and you make a copy, by default, R is not going to duplicate that memory, but it's actually going to just mirror it to say in some fashion.
Okay.
And unless, for example, if you're working with some other types of data might not be very smart. So a data frame, I didn't know this, I just learned this with Emil, but if you modify a column of a data frame, it just like creates a copy of the modified column, but the other columns, since they were not modified in the two copies, they will be pointing to the same space in memory.
Okay.
So that's really cool.
It's more memory efficient then, or
Yeah.
they've made it more memory efficient.
Yeah, yeah.
Well, part of the reason why that is happening is because R doesn't really treat a data frame as a unit. It just keeps the variable as units.
Right. Yeah.
Okay, that makes sense.
So even if you shuffle around a data frame column-wise, R still sees the memory as the same.
Right. Which will become again very important as you start like working with larger data sets. So if it is small data set, it's fine. You can keep like multiple copies. But again, if it's a small, I don't know. So one thing that I usually have is that I have a single R script that I'm like modifying, updating the data. And if I like make a mistake, then I just rerun the entire thing from the beginning. And I usually do that like frequently. I will restart the R session, rerun everything to make sure everything makes sense. So as long as your data is small, if it is bigger, then that we're talking about different things. So, and you will see also tomorrow with, I think that Karen will mention it, but when you are also working with the neat R, because you might have some parts of your code that take longer to run. So there are ways of like storing the results, but you will see that tomorrow. I'm just stepping ahead myself. So
yeah, was it? In terms of storing multiple data frames, I wouldn't suggest doing it. I'm only doing it here just for exemplary purposes. Typically, you probably want to store the raw data, the one that like you read from a CSV file or an Excel file. Then typically what I do is that I then like have my clean the data, which is just all the things that I've piped together to make it the data that I really need to use for the analysis. I do that just so I have the raw data saved. So in case I need to look at anything that I did, I can look at the raw data. And then I have just another data frame, which is the one I'm actually going to be using later on. And that's usually what I would have saved in my environment. Again, if you're looking at small data, by small, I mean like thousands, it's not going to take up, and if you have a good computer, it's not going to take up that much memory. But if you're looking at high dimensional genetics data or genomics data, you might not want to create, several different data frames that only have a minor difference. So
yeah, it's a good point.
I have a quick question. So in regards to like keeping your environment clean, once you start working with like larger data sets where you're doing analyses by like certain factors, do you just recommend like keeping your data frames in like lists and just accessing them by their like list indexes?
Yeah. So that's a thing that I would do. So I usually I work with, for example, with networks, and a lot of times I will have like dozens of networks. So instead of having them loose everywhere, I keep them in a single list. And the same could be true for a data frame. Yeah.
Got it. Okay.
So I'll just go over this really quick, the final exercise before we wrap it up. So here, I'll just go over this in like a minute. This is how you would do it using the same template that I had here. Your code might look slightly different. That's totally fine. As long as you get this as your final values, these should be the final values you should be getting. But here, what I'm doing is I'm piping, instead of replacing price, I am creating a new variable, CAD, Canadian dollars, and that's equal to 1.33 times price. I'm filtering by caret greater than 1, clarity greater than equal to VS1, and cut greater than good. I think that was the criteria that I wanted. And then I wanted to group by clarity and then create the average price, which is AVG price equaling the mean of the Canadian dollars. So if you were to open up Diamond's final, you'll be getting this nice little table, 4x2 table that has the clarity and the price. From here, we're going to use ggplot to plot the Diamond values. So here we have, the x-axis is clarity, y-axis is price, and then G on point, and then the labeling here is clarity and average price in dollars. Nothing surprising here. You would expect better clarity to be more expensive. whether or not this is a linear trend or a non-linear trend. You could look at these things later on. It seems like the trend is linear. So going up from VS1 to VVS2, at least in this data frame, seems like it's going to be the same as going from VVS2 to VVS1. So this is how you combine both what we did yesterday with what we're doing today. Some parting comments here is that dplyr is a necessity for data management, manipulation, and cleaning. We learned some of the most popular verbs that dplyr has to offer. There are some other things to talk about. There are several functions that are in dplyr that I haven't talked about or covered in this talk. So you might think that, oh, like what if I want to arrange the data? Oh, what if I want to look at the number of subjects in the data frame? What if I want to look at just the top 2 rows of every group? All of these are available, but you have to look at the cheat sheet to see how to do this, or you could Google. Google is a great resource to do this as well. Some supplemental packages. dplyr is like a dplyr for data tables, which is what I would recommend using when you have larger or high dimensional or big data. Stringer is a supplemental package that allows for string manipulation. So if you want to like detect certain strings, remove underscores, you want to split strings into 2 parts. Typically, when you look at like a chromosome, it's like 22 : position, location, : other variables. You might want to just extract those independently. tidyr is good if you have wide to long data. So if you want to have data that goes from a wide format to a long format or vice versa. Again, tidyverse is the suite of R packages, so including dplyr. I think tidyr as well, but it also includes a whole other list of R packages that are developed to make data wrangling and manipulation easier. And I think that's all for my presentation. We have 2 minutes left, and we can just take a few questions now. So yeah, thank you guys. Okay, so I think for Nono's question about ordering, does ordering matter? It depends on the function. In the case of lists, if you wanted to filter or mutate, it wouldn't make a difference, right? Because mutating is just changing that variable and it's not dependent. As long as they're not dependent on each other, it'll be fine. So in this case, if you were to filter before mutating, that's not gonna change anything at all, right? Like the price in Canadian dollars doesn't matter if you only looked at a subset of a subset that's not based off of it, right? So here, if you wanted to look at caret, clarity, and cut, you meet this criteria, and then converting the price, that's not gonna make a difference. But say you wanna summarize the mean. If you do the mean first, and then you were to filter by if you were to do the mean first, and then filter by the price, or price filtered by the mean, if you were to swap those, that's gonna change, right? Because when you do like let's say you want to look at prices greater than 2,000 and then doing the summary, that's going to be a lot bigger because you're only looking at a subset of prices that are greater than 2,000 to start off with. So depending on if the function is dependent on anything beforehand, that's how I would see. If they don't, then you can easily interchange these. Is filtering done on each consecutive filter, sort of going down the line of code and filtering, or all at once? It depends on the way it's written. So like this is written in the sense that you're looking at anything that meets all 3 criteria, I believe.
Yes, I think that's correct. It constructs the expression and then filters according to it.
Mm-hmm. Yeah, I mean, if you think about it, right? Like if you looked at all 3 of these expressions, caret greater than 1, clarity greater than equal to this, if you were to do these independently, you'd still get the same result because it's an and, right? So that subset is always going to be shrinking as you have more and more restrictions. As long as it's like an and type of argument where you're looking at 2 things being true or 3 things being true, it shouldn't make a difference on whether or not you're doing all of them at once, or if you did 3 separate filter commands, each filtering like, this first, pipe filter this, pipe filter this, those should all be the same. It'll only be problematic if you're looking at or, where you're, saying, oh, like caret being greater than 1 or clarity being greater than VS1, because that will take a different set that might actually change as you go down the line.
And I think the last question is what happens to the groups after you do operations after the group by statement. So in previous versions of dplyr, like a couple of months ago, if you did like a summary statement, the summarized statement after group by, it would drop the last group. So if you group by multiple variables, you would group by everything but the last of the group variables. Now is dplyr being a little bit more explicit about it. So when you're setting, I think it's in the group by, no, so when you're doing the summarize statement, you have a .groups argument where you specify what happens to the groups after. So you can say, when I summarize according to these groups, I want to drop all the columns, or I want to drop some of the columns. So it depends on the arguments you set.
Let's see if I could pull up something really quick. Also, like I you know, it's past 11, so if you have to go, feel free to head out. I understand that people have other things to do during this time. But let me just try to see if I can have an example. So we can pull. I'll just pull this example really quick. I'll stop sharing my screen. I'll share a new one. So this is something that I did. For those of you guys who are interested, if you're not, totally fine. It's kind of an extra credit. Let's go to desktop 2. Okay, so here, I hope you guys can see my R screen. I will try to open it up. But this, you know, what I'm doing here was I was looking at COVID-19 data that was given to you by John. That was, you know, the Johns Hopkins has a public repository of number of cases. And so let me actually update to the repository to see if I get the most recent data really quick for those of you who are interested. So, so I was, you know, trying to see if I could recreate these plots of incidence of COVID-19 and also deaths. What you can see here is this is kind of what I did with my data. And I'll show you just like a real world application of just using dplyr in action, I guess, right? Like everything I showed you was more just like temporary data, things they don't really care about or look at. But this is like a real, you know, a real example of how you can use this data that we have. So let me actually open, I think case count, is this the one? Analysis, I think this is the one. All right, so here I'm opening this data frame, and in this data frame we have all these variables, all these, just, you know, here's all the columns, here's all the IDs, here's all the rows, and this is a longitudinal data set we have going from January all the way to, I think, I don't know what the most recent time is, but let's just do this really quick. 2:15. That doesn't make sense. Names in US cases. Yeah. All the way to 8/11. And so I'll just show you, like, you know, I'm using string replace. You know, I'm getting these. You can see that my code is all using dplyr. Like I'm using dplyr to clean this data to get what I really want to get. I'm doing a lot of selects. I'm doing a lot of filtering. So you can see that I'm doing filtering. I'm selecting certain columns. I'm summarizing certain things. I'm filtering again. I'm selecting. And I do all these things just to get the data that I need, right? The data that I have here is not nice at all. It's very ugly. And I'm able to do this. And then once I run all my code, I'm able to get a plot like this using clean data. And this clean data is given to me over here in LA cases, or US cases, I think US cases is a bit cleaner. Yeah, and so what I do is that I'm just transforming the data that I get, which is not what I need, to give me data that I want. And this is just like a real world application of why it's important to use this because, you know, if you want to do certain things, it's easy to see why you need to do it without really knowing, or it's easy to like be told what to do without really knowing the application of it. And this is just a really quick application of like what I actually do, and how I could use dplyr to do what I want to do a lot more efficiently, or a lot easier. So that's just a really quick example for those of you who are interested. But you know, I'm using stuff from stringr because there's a lot of strings here, especially with the dates. I'm filtering based off of just looking at the United States. I'm selecting certain provinces or states, and then I'm creating new data frames over here based off of the values that I have to be able to create the plots that I want to create. So that's just a really quick example of how I use dplyr in my own personal research.
Yeah, I think that at least from my experience, that the best way of learning this is with an application. So if as soon as you actually start trying to use it for your own stuff, the quicker you will learn. That's at least the way it has worked for me.
Mm-hmm. Yeah, so just to ask Nono's question about what the string replace all function was doing. So what it was doing was essentially the dates looked something, I guess I'll share my screen really quick briefly again. If you look at the dates here, so if you look at the names of the US cases, they all look like this, right? It's X 8.11.20. And this isn't like how I would really want to see my dates, right? My dates, I want it to be like 8-11-20. And so I'm just replacing certain parts of the string. So what I'm doing with string replace all is I'm saying that looking at this variable, so, well, first I want to only select the columns that actually have an X in front of it, right? So it starts with X because these are where the dates start with. And what I want to do is anywhere there's an X, I want to just remove the X. And that's what X equaling quotes with nothing in it means. And then all I'm saying here is that anything with a period in it, I want to switch it with a slash. And so in doing so, I get dates.idx. I create a new vector dates.idx.
Yeah, you're not.
Sorry.
You're not.
Okay. Yeah. Got it. Okay. Is this better?
Yes.
So here we can see that the names all look like this. These are the dates, x.2.28.20. And these are things that I don't want. The reason why it's like this is because for data frames, you can't have a column name that starts with a number. If you try it, it'll automatically put like an X in front of it. So these are all dates, but they have this extra X in front of it that I really don't want. And so I want to create a vector of dates that look like 8-11-20 or 8-10-20, right? I don't want it to look like x.8.10.20, especially if I'm going to use this to create like my axes. So what I do here is I replace all the column entries that look like x dot something, and I want to first remove the x, replace that with a blank, and then remove the dots and replace that with a slash. And in doing so, I get dates that look like this now. And these are more like the standard way of looking at dates, right? 8-11-20, 8-10-20. And so that's what I'm doing with string replace all. I'm just replacing all the strings that have a certain thing with something else. Someone else also asked about me sharing the data for COVID-19. That data, so what about names? Can you give me like an example of what you mean by names? But someone else asked me, while we're getting that, someone else was asking me about the COVID-19 data. This is given to you. This is free from Johns Hopkins. If you go to their, so let me go to the repository.
Yeah. We can share that by email later.
Yeah. I'll share it by email, or I'll just I can send it to the link. I believe this is it. Yeah, so this is the GitHub repository. Oh, sorry, names. Yes, the names function. The names function is just getting all the names from the data frame. So in this case, these are the names from the data frame. But I only want to look at the ones that start with an X in front of it. At least in this data frame, that's where all the dates start. It might be different based off of what you're looking at. So I'm, in this case, remember that the select is subsetting columns. So I'm only extracting the columns that have the X's in front of them. And that's what starts underscore with X stands for. Yeah. Yeah, so I hope that was helpful. Yeah, don't want to go over too much time. Everything else here that's based off of the COVID-19 data, like just, you know, here is the GitHub repository. The link is, I'll send the link to everybody, whoever's interested. Don't, you know, I don't want to spend too much time for those who aren't interested in this.
So you can send questions by email to Eric afterwards if you're interested.
Let me just, I should also put my email.
Yeah, if you share your email on the chat, if anyone has questions. I think I've been copying Eric as well when I send the emails with the announcement. So you should all. Is it with med.usc.edu?
There's two. So I have one with, and then my other. I have another USC account. Yeah. The med. So I've been having issues with my USC account where I can't get anything that is third party or not USC. So I don't get emails from Gmail accounts. I don't get emails from med.usc accounts to my regular USC email address. So it's very odd.
So this is more stable then?
Yeah, the med USC is more stable. So you could email me with any, for the most part, any email address or, you know, like